Hi, the doctor's in. I'm Dr. LB, and I'm here to help you through your math difficulties. Today, we look at graphing systems of inequalities into variables. So, a system of inequalities will contain two or more inequalities. And what we're going to do when we graph the solution set is we're going to graph each inequality individually and then what the two regions have in common. That's what the solution set is going to be. So let's look at this problem. Here we have x minus y is greater than or equal to 4. That's going to be a dashed line. X plus y is less than, a solid line. X plus y is less than or equal to 6. That's going to be a solid line as well. So let's graph these two lines. Let's look at x minus y equals 4. And we can use intercepts. If x is 0, then you have negative y is 4, or y is negative 4. If y is 0, then you have x is 4, so you have a point 4, comma 0. So 4, comma 0, 0, negative 4. This is a solid line. Now let's test our origin 0, comma 0 into that inequality. We have x minus y, 0 minus 0, so 0 is greater than or equal to 4. That's a false statement. So we're going to shade the opposite side of 0. And I'm just going to draw some lines like this to denote this is what we're looking at. Okay? Let's look at the next one. We have x plus y equals 6. So if x is 0, then y is 6. So we have a point 6, comma 0. If y is 0, then x is 6. So we have a point, this should be 0, comma 6, and this should be 6, comma 0. So let's graph this with a different color. 0, 6 is here, and 6, 0 is there. Remember, this is a solid line. And now we need to test to see where we're going to shade. So if I test 0, 0 into the second one, I have 0 plus 0 is 0. 0 is less than or equal to 6 is a true statement. So we're going to shade the region of this purple line where 0, 0 is located. Now, we don't have to shade the whole region. Remember, this is 0, 0 right here. We don't have to shade the whole region. We need to shade the region where there is blue shadings. So here, we're going to shade this region. As I said before, the graph or the solution set to a system of linear inequalities, it is where the two regions meet. So where you see purple shadings, this is our solution, the purple. Let's look at another one. Here we have x plus y is greater than 3 and x plus y is less than negative 2. So here we're going to have dashed lines in both of these situations. So let's look at x plus y equals 3. If x is 0, y is going to be 3. And if y is 0, x is going to be 3. So we have 0, comma 3, 3, comma 0. And we said these are dashed lines. Let's test the point, 0, comma 0. We have 0 plus 0 is 0. 0 is greater than 3 is a false statement. So we're going to shade the region opposite 0, 0. Let's look at the other line. X plus y equals negative 2. So if x is 0, y is going to be negative 2. And if y is 0, x is going to be negative 2. So we have 2 points, 0, negative 2, and negative 2, 0. And this is a dashed line. And let's test the origin, 0, 0. So we have 0 plus 0 is 0. 0 is less than negative 2. Is a false statement. So we're going to end up shading the region opposite 0, 0. Now, if you notice, the purple and the blue, they don't meet. They have no regions in common. So what we have here is no solution. This set of inequalities has no solutions. Let's look at another one. Here we have y is greater than or equal to x squared minus 4. That's a parabola. It's going to be a solid line. And we have x minus y is greater than or equal to 2. That's a straight line, and it's going to be a solid line as well. So let's look at y equals x squared minus 4. This graph contains, it's a parabola shifted 4 units down from the origin. It crosses the x-axis at 2 and negative 2. So this is a solid line or a solid boundary. That's our parabola. Now let's test the origin, 0, comma 0. When we do that, we have 0 is greater than or equal to negative 4. And this is a true statement. So we're going to shade inside of the parabola where 0, 0 is located. That's called the cup of the parabola. Now let's look at the line x minus y equals 2. So if x is 0, negative y is going to be 2, or y is going to be negative 2. If y is 0, x is going to be 2. So let's plot these 2 points, 2, 0, and 0, negative 2. This is a solid line. Let's test 0, 0. So 0 minus 0 is 0. 0 is greater than or equal to 2. And this is a false statement. So we're going to shade on the side of this line where 0, 0 is not. But we're only going to shade where they're blue, where we have blue. So really, this portion here, the purple that I'm shading in, will be your solution. The purple shading. All right, let's look at another one. We're going to look at one that contains 3 inequalities. 2 of these are straight lines. If we look at x is greater than negative 2, we're going to have a dashed line. But x equals negative 2 is a vertical line at negative 2, and that's going to be dashed. And then all values greater than negative 2 will go out. And I'm just going to say this. It's going to go out to the left, to the right. But let's go ahead and we can test 0, 0 since we've been testing. Let's test 0, 0. So 0 is greater than negative 2. is a true statement. So we're going to be on the side where 0, 0 is located. Now let's look at y equals 4. Y equals 4 is a horizontal line at 4 is less than or equal to. So we're going to have a solid line at y equals 4. And again, it's less than, so we know it's going to be under. But if you want to test 0, 0, you have 0 is less than or equal to 4, which is true. So I'm only going to go down here where there's the blue. Okay. Then our next one, we have 3x plus y is less than or equal to 6. So let's draw this line. We know it's going to be a solid line. So if x is 0, then y is 6. If y is 0, we have 3x is 6, or x is 2. So we have a point 2 comma 0 and a point 0 comma 6. We're going to do this in black. And let's test 0, 0. We have 0 times 3 plus 0 is 0. 0 is less than or equal to 6 is a true statement. So we're going to end up shading where 0, 0 is located. And I'm going to shade this in yellow. And only where the purple and the blue meet where this yellow go. So this yellow is going to go here. This is our solution set. So remember that Dr. LB is always in. Please come back for more math help.